Welcome. We'll introduce ourselves in a second, but today we're here to talk about sustainability and open source. Let me see. When we first put this presentation together, this is actually the second time now that we're presenting this, but when we started to put this together, we really wanted to focus on three main topics. Sustainability, why that's important. Open source and its role in sustainability or energy management and why that's important. And then talk about just some basic ways you can get started. Not really knowing the nature of our audience, we think from an open source perspective, pretty much everyone here knows what they're talking about, right? But in the sustainability realm or the energy management realm and in the IoT realm, which is where we come from, we kind of took it down to a very basic level.
All right, so thanks everybody for joining. So my name is Bharat, a quick introduction about myself. So I'm a senior manager at Deloitte Consulting. I've been working in the field of energy and IoT for the past 15 years. Over to you, Joey.
Yeah, my name's Joey Bernal. I'm actually Anthony Bernal, but I go by Joey. Also with Deloitte, senior manager. Together, Barath and I, along with one of our other colleagues, we run the IoT offering. We kind of lead the IoT offering for our group within Deloitte, Germany. So we work with customers really from an IoT perspective, and for us, energy management, monitoring and management is one element of that.
All right, let's get started with the energy crisis at the moment. So if you look at the numbers, the global energy consumption is about 177 terawatt hour. Just to give you a perspective, the population from 1950 to now has actually doubled, but then the energy consumption has gone up by 5 times or 500% increase in global energy. And then there's also a 37% increase in manufacturing industry, which is the major consumer of energy. And the prices have also got increased, which means that we pay 23% more in terms of consuming the same amount of energy. So there is an imperative for us to build sustainable solutions which are innovative and at the core of what we see as sustainability for the years to come. So now let's look at the why in terms of what are the reasons why we need to look at energy management.
So from a why perspective, right, I think Bharat just showed you or talked to you about the crisis that we know we're all facing from an energy management or sustainability perspective. And there's lots of reasons for this type of monitoring and measuring and metrics. And we really debated a little bit whether we go into the metrics and the KPIs and the measuring capabilities, but we thought we would keep it very simple for this presentation. I mean, cost is probably a big factor, right, for measuring or monitoring your energy usage, whether it be electricity or gas or some other consumable. Compliance is obviously one, but sustainability, and that's what Barath was leading to, is probably key for another factor, right?
So what you see here is, of course, it's an AI-generated version of a smart city or a smart town. But what you see is pretty interesting objects or subjects here. So you have a lot of data source, energy-producing sources, like the windmills, the gas stations, the coal power plants, and so on. And there are also renewable energy providers, independent energy creators that actually supply energy back to the grid. And then you also have the grid operators, the distribution systems, the transmission systems, and also the end consumers who actually consume energy, the industrial usage, the commercial usage, and also the residential usage. So it's a very complex network of interconnected entities which need to connect, and open source is actually at the heart of this such an ecosystem. So we will now look at individual players in the next slide, where we talk about the various aspects that we just spoke about in the previous slide that interlap here. So on the left, you have the energy generators, the renewable energy providers, and also independent providers that are coming up today. Whoever has a farm, they can actually put up a solar power plant and then feed back the energy to the grid and make money, right? So that's on the left. So at the bottom, you have the consumers, the industrial consumers, the residential consumers, and so on. At the core, you have the transmission systems, the distribution systems, the grid operators, the energy traders, and so on. So it's a very complex ecosystem where you have the governance as well on the right. And then you have the technology providers that work like us, who will work on consulting, work on industrial IoT, and help bridge the entire ecosystem in place. and each of them speak a different language. But now today, in order to bring focus to this particular topic, because it's pretty huge, we are going to focus only on the industrial vertical sector and probably the building sector. So the next slide talks about the highlighted uh, sectors that we are going to cover in today's talk. Next up, we are going to also talk about successful case studies that we have done in the past in this area that's highlighted in blue. So one such case study is about manufacturing plant operations. So we used to work with a company that had a lot of production lines. So, but then there were a lot of energy wastages that were the pain point of the consumers. So what we did was we had the entire production line mapped out, added energy meters to each of these lines. So what we built out of it was to have a global view of how energy got consumed, and we were able to identify asset level inaccuracies, right? So we're comparing 2-3 production lines and say which one was more efficient for the same amount of throughput that each of the line produced. And this helped us to narrow it down based on energy. Some of them were legacy machines which did not have intelligent data. So only by use of energy we were able to make the operations more efficient. So the results were really spot on. We were able to reduce their energy bills by 12%. The solution paid in itself. The ROI period was very short, and this gave us a lot of impetus towards building solutions on open source. So a similar case study, but this is more towards smart cities and buildings. So we did this at a university campus. So there were a group of buildings, around 50, 60 buildings within the university campus, but then they were having inefficiencies in terms of HVAC and energy usage within their buildings. Right, so we utilized OpenHab as one of the providers in order to kind of hook up the HVACs and automate them. And we also integrated that with the weather API and also made sure that we were able to mix and match based on user requirement, user comfort, as well as the efficiency that it provided. So this was also a solution that was built on top of open tech stack. The third case study is probably pretty interesting as well. So Joey can.
And so in a previous life, I've been working with IoT probably 2008, 10. We didn't call it IoT back then, obviously. I was the chief programmer for an IBM product called the Intelligent Operations Center. So smarter cities was kind of the thing back then. And we were trying to integrate not only energy, right, electricity and gas and water, but also sewer and fire and all those things from a city perspective. So we've been working in this realm for a long time. One of our earlier projects, I want to say 2014, 15, somewhere in there, was a community-based energy portal, which was an interesting adventure in terms of trying to measure and monitor sustainability for a very large waterfront revitalization effort. And so new buildings, new parks, and things were going into this community, and so we made an effort to try to integrate as much data as we could, make it public domain, and measure it over time, integrating with Energy Star, adding sub-metering where necessary. A very noble effort. We actually ended up running into political and privacy issues, which kind of had us abandon the project. But the goal is there, right? And I think the goals are still there. But it was lessons learned in terms of how do we make sustainability across the ecosystem that Bharat talked about earlier when he showed all the different players and how they can work together. How do we make that a reality?
Yep. So right now we have looked at what the energy management ecosystem looks like. Why do we need to look at energy management for sustainability? So we will now look at the challenges and considerations that we need to look at when we choose open source as the medium for developing a solution like this.
So why use open source? Right? I think we all know the answer here. Not only from a commercial or a cost perspective. For me, one of the driving factors here is this idea of open architecture. And again, I go back to the slides that Bharat showed earlier that show all the different players and the integration and how we can leverage this data that we collect and use within our own organization. Even if we just use it internally, we're getting value from it. But if we can use it to collaborate with providers or traders or prosumers, then we're getting even more, and we're leveraging the entire ecosystem. And I think open source helps from that perspective, right? Aside from the cost perspective that I mentioned, it's this idea of open architecture that we may not get from a proprietary or commercial system. So it gives us that flexibility as we move forward to potentially, expand.
Yep. I want to touch upon this a little bit more, just to add the analogy of a tip of the iceberg here. So the previous slide gets much bigger if you zoom out a little bit. So on the top, you have the surface where you have things that you can actually feel. These are the value drivers. So you talk about customization, the ability to work as a community. So these are the perks that come, as everybody knows, working with open source community. And we also want to reiterate what Sarah just mentioned in the keynote, where we also need to give back to the community when you start consuming open source products. But then below the surface, there are things that work with, say, things like issues like monetization, license management, long-term support, which also need to be taken into consideration. So the aspects like community challenges and also the human aspect, right? So when you work as a community, so there is also an imperative to make sure you collaborate, but then you also have a freedom of choice. You have two things at once, and you have a choice to pick which one you want, right? So these are the entire stack list that we are trying to kind of pursue in terms of the challenges and the possibilities that open source provides. And then we need to have a balance between all of them here. So this is the open source paradigm for you guys. So next we deal with the challenges specifically with respect to energy management, whether it is open source or not open source.
Yeah, I think from a challenge perspective, again, there's no silver bullet. There's no easy answers here. We work with customers who use open source every day, and some of our customers are moving away from commercial systems to open source within their factories, within their plants, aggregating data or collecting data throughout their environment. But there's always this level of trust. I think Sarah talked about trust in her keynote earlier today, about trust but verify, kind of with the open source space. So making sure that when you do deploy or use open source, regardless of whether it's a brand, a very well-named brand, we'll talk about some of those later, make sure that you have scanning in place, that you have your own private repository versions of these things, and that when new releases are coming out, that you're not just throwing those out without verifying, especially if you're putting it into shop floor environment. In addition, again, nothing new here, I think, for most of our listeners, but scaling issues, technical expertise. Obviously, there's not always a vendor there for these types of things, depending on the type of software you're using. Right? There are commercial versions of some of the software that you can get support, but that's not always the case. Especially if you have a customer or an architect who's very aggressive and kind of likes the latest thing, right? In terms of, hey, this is brand new, but it looks great. We're going to use this. So those types of things have to be considered within your architecture.
Yeah, so one more topic before we get started is I wanted to highlight on is the integration complexity. So we used to work with an engagement where we had multiple players or multiple ecosystems partners working on. So integration was the biggest challenge because everybody spoke different languages, all the APIs were closed and so on. So when we shifted to an open architecture, the biggest advantage that it provided was the integration easiness, right? So we had a common language to talk to, a common data model that everybody was able to follow, and then each of us had their own applications, own targets to develop on, but this becomes really fairly straightforward building on open source. So let's now look at how do we get started. We will talk about a few practical case studies of what we did or how do we get started. So this gives us an impetus for everybody in the space to build up applications from scratch or from a brownfield perspective.
So this is kind of where we live, right? This is what we do every day with customers. It's as close to a sales pitch as we're going to get in terms of talking about what our roles are within Deloitte. But I like this idea of 6 weeks to value because we kept it very simple here, right? We're keeping it a single measurement or a single set of measurements on a single machine or part of a machine to show that you can do that. If you don't have any systems in your shop or in your environment today, this is where you start, right, in terms of pulling data, and we'll show you some examples of some of that. Now, what we don't really talk about here today is scaling, right? Because then it becomes a whole, it really becomes a proof of concept that you can throw away potentially and start from scratch. But these are the areas where you might want to think about from an architectural or technical standpoint, right? So your IoT architecture in terms of your broader architecture or your long-term architecture. It doesn't have to be day one or your first pilot, but it's something that has to be thought through as you prove the value and start to scale. Shop floor data access. So how are you going to access this data and how are you going to do it at scale, right? The things that we show today may not necessarily be things that you would do on a large scale, right? In the hundreds or thousands of elements, and we'll talk more about it when we show those. And then how does that data flow within the environment, within the manufacturing environment, up to potentially the cloud, or where does it need to store? The cloud connectivity and data management, are you putting that into a data lake or some kind of warehouse, or how are you storing that? And then your value-driven use cases, your analytics, once you have the data flowing, right? I mean, we're just looking at simple dashboards here to monitor your usage, but when you start to collect that data, you start to want to get more value from it. Digital twins, predictive analytics, things like that, especially from energy data. So you can do a lot with just this energy data more than just sustainability, right? You can really start to do predictive analytics and see how systems
As we saw earlier, I think with energy data on a legacy plant, we were able to optimize their entire production line, look at OEE, where the efficiency was coming down just by looking at energy data. So you look at power quality, you look at power consumption, and map it with throughput. I think there's a lot energy can actually tell about the entire operations of production.
Yeah, it's not part of this talk, but motor current signature analysis is a well-known machine learning algorithm. I'm getting the data anyways.
Yep.
So why can't I run some machine learning models on this data to see if there's problems with my machinery as I'm working?
So we saw the 6 weeks to value in the previous slide. So right now, let's break it down into, say, concrete actionable items. So we have fields 1 to 6. So the first one is always to identify the problem that we want to solve. So without the right problem, we might have the entire technology ecosystem data available, but without the right problem and the right stakeholders, I think it's very fairly non-successful to venture into any project. So the first one is to identify. The second one is to set KPIs or measurable or quantifiable values that the stakeholders would like to perceive, because this is the step that we often foresee and we often do not foresee, and we also miss the sustainability angle to it, right? So in order to make sure we achieve the targets, we also need to quantify what would be a possible outcome. As simple as I want to improve my carbon footprint. I want to reduce my carbon footprint. I want to become net zero by so and so. So what it entails it to is to break down that particular target into things that we can actually quantify and then achieve. Right? So these are targets that are really important to set. So set goals is number 2. Number 3 is to kind of derive the value system, both quantifiable and quantitative goals and qualitative goals. So these are the KPIs and metrics that we talked about. And fourth one is the right technology, right? So this, all of them comes down to the choice of the technology. So as Joy mentioned, so it also depends on who is in the team, what is the preferred choice of technology, and so on. But what open source gives us is a variety of open source ecosystem to choose with, but also players that have data interoperability with the common shared platform goals, right? So we'll be able to look at the right technology players, the right platform, the right vendor ecosystem, the right support partners, and so on. So to put together a collective architecture. So in the coming slides, you'll also see sample reference architectures that we built for you guys to look at what could be an open source energy ecosystem that can still work with your enterprise applications, but still exist to provide value in terms of energy and sustainability. The fifth one is, again, we want to re-emphasize on this topic, build in public. So what this entails to do is to kind of bring in ideas from elsewhere as well, from the outside community. So whenever you make a project open source, as you guys know from the Eclipse Foundation, so there is inherent value from the community with collective brain sharing. So you will together make better products, and then we can also contribute back in terms of looking at how do you fix bugs, how do you develop your roadmap, how do you validate your roadmap with a bigger set of community. And finally, I think scale and operate. I think this is what we did not want to touch, but then just to highlight here, I think whenever we build a product, it should not end with a proof of concept and a proof of value, but then it should be really operational and scalable. And I think the open source community is there to take care of how do you kind of, there are a lot of projects that have been really successful, and then we can templatize this model and then follow this for the entire success.
This slide just touches on the surface of what you need to do before anything, right? And I think there's a whole world within this assessment and planning in terms of workshops or analyses that need to be done. Consultants would love to work with you for months or longer to determine, what's your sustainability rating and how you want to go about improving that over time. So that effort really does need to be considered, as you move forward. It's one thing, and we'll talk about this in a minute, it's one thing just to pick a simple use case, right? I need to go down, talk to your operators on the shop floor and say, I want to pull data from one machine, and talk about what that might be. But the reasoning behind that and what your long-term vision as an organization is going to help drive that, from an organizational standpoint. So next piece is getting hands-on, right? Getting started. And this is really, if you don't have experience on the shop floor, this is great learning. This is a great place to start. To really start to integrate and work with people on the shop floor and start to collect and pull their data. I think I've learned over time, working with many different industries, once operators start to see their data in the formats that we're going to be showing, they can't live without it, right? So working with them hand in hand to determine what your pilot piece is going to look like, and how you're going to pull that initially, and remember this is pilot, is your first step, right? And this diagram here is really your 6 weeks to value kind of vision. Can I do this within 6 weeks? 6 weeks is actually, I think, a little aggressive, depending on the industry or the organization. Sometimes it takes a lot longer just to get permission to get things down and done, at that level.
Yep. So what we have here put together is an open architecture for energy. This is just a reference architecture that we just built. So just putting in the pieces here. So the bottom shows the energy network, all the players that we initially talked about, the EV infrastructure, the distribution system, the transmission system, the solar renewables, and also the transformer grid. So these are the various major components that generate energy. And then you have the sensor layer on top, which is the energy meters, the open PLCs. Open EMS is actually a pretty good community which develops open hardware for energy management. So if you guys have not known them, I think it's pretty good to explore. And we also have other data that can be collected, say, from open weather APIs, IoT sensors, and so on. So this covers the sensor layer. On top of that, you have the compute layer, which is the edge layer, where you could use open source, and we built the stack from ground up. So this can also be packaged with smaller variations based on existing tech stacks that you already might have. So this we have broken down into two aspects. One is the infrastructure layer, which has the operating system, the containerization, the tools that help you to scale, deploy your applications, manage your applications at scale, and so on. And then at the top, you have the Ming stack, which we will talk about in the next slide. But then this gives us the primordial ability to kind of acquire data, store data, process data, and then visualize data into applications. Right? So this is at the edge. Then you also have the cloud compute layer. We also have experience working on the edge management from Hawkbit, and also connecting with, say, enterprise applications, because already there are applications that are running in any of the enterprise, right? So you have your ERP applications, you have your hyperscaler applications, and so on. So this cannot coexist on its own. So whenever we need to look at a solution that coexist with the entire ecosystem, you need to build interfaces that can kind of talk to or send data or exchange data from these enterprise applications. On the top, you have this plane for user applications. You could build, so for example, the university application that we built was on OpenHab, which is the automation layer that actuates HVACs on demand in order to make sure you are able to optimally run your HVACs. You also have the energy management from Emon CMS, which gives you pretty easy graphs to work with. It is fairly configurable there's not much of hands-on developer experience that is needed, but still it's pretty useful to kind of build your graphs and then visualize what is really important for you. Right. So this is the entire tech stack from the infrastructure layer to the data layer to the compute layer to the storage layer and then the application layer. So this is something that we want to showcase to you. Next up, we'll dive deep into the actual Ming stack to look at how we can leverage the Ming stack for energy management.
So the Ming stack is very popular in this space, in the IoT space. And again, for me, different for Bharat, energy monitoring is just an instance of IoT, right, or industrial IoT. And I think Ming, which stands for Mosquito, Influx, Node-RED, and Grafana, is kind of the de facto standard, right? Although many people will swap out Mosquito for EMQX or a different MQTT broker just because they don't like Mosquito or they don't think it's robust enough for production. So these elements here really allow you to get started quickly and easily. When we look at this stack, we think of shop floor, right? We're putting servers, maybe a Kubernetes cluster, something in the factory, right, or in the shop floor, and this stuff is driven local, including Grafana, which is for our visualization, which operators can see directly. It doesn't have to be; it can be in the cloud, right? But it just depends on if you have a customer, a manufacturer, which many of our customers have dozens of plants. So we're always thinking edge-driven, and then we'll move data to the cloud as it needs to be analyzed across the enterprise. There's other elements, and we'll talk about those as we go through, but there's a whole stack based on the model, the Purdue or the ISA 95 model that Bharat just showed us in terms of the levels of hardware and software at each of those levels. And so it becomes a bit of an analysis. There's a lot of easy off-the-shelf stuff or out-of-the-box stuff you can do to make this happen, to get this initial 6 weeks to value that we talked about. And in some cases, it might just be a religious war, right? And I had some of those yesterday in terms of talking with some folks about, is this better than that? And it's like, just pick one and go. So it's kind of pretty easy to get started, run your proof of concept, and then define your long-term architecture as you go.
Perfect. All right. So next up, we also wanted to kind of talk to you about one of the projects that we implemented for legacy manufacturing. So we leverage this product called Emon CMS from Open Energy Meter. So this is a product that's a very strong community that's been running. So they are also launching their newest version of the hardware in Q1 of 2025. Pretty good to kind of hook up even for your residential usage purposes as well. So the whole server can be hosted on a Raspberry Pi. The image is open source. It's available for us. And the good thing about it is clamp-based energy meter. So you can just clamp it on to the power line and you can start measuring energy. You don't have to break in or you don't have to add or modify your wiring in your setup and so on. But what this gives you is the power of what we just talked about, right? The entire data set from the real-time energy data, the parameters that are needed. And then you can also build your custom automations around it to say, okay, this is the time I need to operate my loads so that the energy bills are less. So there are also instances where companies have pre-booked their energy power based on their demand. So you have an historical analysis of how your demand maps with your production, and then you pre-book your power, and even €1 per unit that gets reduced is actually a huge saving at the end of the day, right? Your top line and bottom line, I think there's a huge, tremendous improvement with that. So I think this is a good, I think this is something that here's, yeah. So this is actually running in his house. So you have the graphs coming in.
These are the particulate matter in my house happens to be. The clamp-on meters, the current sensors, like Bharat said, they're great for environments like when you have validated production equipment, maybe in pharmaceutical or medical manufacturing, where you don't want to go in and they don't want you to go in and change things, right? So this clamp-on is very non-invasive, a good way to get started, probably a very easy way to get your PLC done really quickly. It's open source. What is it? $150?
Yeah.
$150, and the CMS is free. I like this CMS, this Emon CMS, because it provides a really simple way for non-technical end users to visualize their data. And we know this is a challenge, right? If you're using Grafana or Power BI or something that's powerful, but it takes some learning and curve to really get something useful. This you can see, I think, right here. I just click on some buttons and I can see my data. So that's something that I have strived for. I built a couple of production systems in my life, IoT systems, and it's always been this case of trying to provide the end users, the non-technical end users, with a way to visualize their data and and um, and get value from it without me having to. Early on one of our projects that happened to be water utilities, I would run spreadsheet models, and I would run energy over flow, and I'd build a diagram that looked similar to this, and I'd go to the guy and I'd say, hey, does this look okay? Does it look useful? And he'd say, well, maybe this and this, and I'd run back and I'd do another one. So it's always been kind of in the back of my head, how can I build interfaces so that they can do their own models? And then they could tell me, oh, this is really what I want to see, and then we can go from there. But just something to think about as you kind of move forward. We also added the Opta. We happen to have one. This is one of our workbenches that we happen to have one. It's based on the model that you saw earlier. We just have back here we have a three-phase AC motor with a variable speed controller that happens to have an energy meter connected to it. And so the Opta, which is right here, is connected to this meter. So the operator can see their data at the motor itself. So they can see voltage, current, kilowatts, whatever they need to see. But there's no way to get it out. There's no PLCs here. There's no way to really get that out. So the Opta happened to be a pretty easy way to just do a quick Modbus RTU connection right here to the meter. And I want to say we were talking about it. I didn't count them, but probably 50 lines of code. I was able to pull, voltage, current, watts, convert that from Modbus registers, right, into floats. Package that into an MQTT message, and then push that up into the cloud, which you can kind of see right there, right here. You can see the data coming through. So is it scalable? I don't know, right? It's a question that we talk about. It's $150 if there aren't PLCs on place that you can tap into, or there aren't, or if you don't have the voltage meters, or they're not, internet enabled. Maybe it is a way to do it. Maybe it is a scalable solution. The jury's kind of out, but it was pretty easy to do, and I was even able to go pull from a NTP time server, so I get the current date and time, so I could timestamp my data pretty easily. So it was a nice pilot. I'm just not sure if I love the Opta or not. So and then. Finally, we just want to talk a minute about visualization and analytics. We don't really go into MQTT too deep, or Node-RED, which is a super powerful tool to collect data from some of your sources if you need it. But the visualization piece, Grafana is by far the leader in this space from an open source perspective. A couple examples here, right? We've got the upper example. This happens to be also my house. When I first moved to Germany almost 4 years ago, everybody scared me about energy prices, right? So I instrumented my house with the LoRaWAN network and put sensors on my gas and electricity, built these dashboards, and started watching it. It wasn't too bad, but you can start that simple, right? I mean, it's that simple just to pull data. Now I just go and look at the monthly total and tell my wife what it is so she can pay the bill. But you can see the bottom. The bottom is much more complex and would be much more industry focused across multiple devices or multiple locations, right? The thing with Grafana is the integration capability. I think building the dashboards, it requires some skill, right? It's not trivial, but it's not terribly hard if you have some perseverance. But you can integrate it with almost anything. And the plugins for that integration are super easy and it's free. So I think that's a big bonus here for that. And a lot of our customers are using this. They're building their own dashboards to look at things that I don't think Grafana really thought they should be looked at, or they thought about looked at.
Exactly.
But it's really interesting.
Yeah, we also did a quick competition. There were 13 manufacturing plants, so all of them were competing against each other. So that was a pretty healthy competition built on open tech stack on Grafana. So they were able to compare which facility was more greener, more efficient, and so on. So that's a win-win for both the environment and for the plant. Yeah.
Go ahead.
Yes.
So finally, we just wanted to wrap up, kind of what we were talking about, right? Why is energy monitoring important? I think you can answer that question better than I can in terms of.
Yep. So energy management definitely opens up a lot of doors, not only looking at how you consume energy, but also how you can act responsibly for the future generations, building in sustainability within your product, right? So this is something energy can offer you. You could look at different sources of energy at different time slots, based on seasons, based on the nature, based on your demand, and so on. So there's a lot of things when you start measuring, you'll get an opportunity for optimization. So energy management would be necessary for us, looking at how we are consuming energy in the future and how energy prices are actually fluctuating globally.
Why is open source important in terms of energy management? I think from that perspective, we touched on that, right? Aside from the cost, which is a big factor, it's open integration, right? Or the ability to potentially modify or integrate the software with other vendors, other partners, other softwares. Now, there's a lot on the market, and there's a lot of talk about integration, right? Using MQTT or REST or those things, but those are also all kind of open source driven, right? From an MQTT perspective, especially. And then finally, how to get started.
So we showed you the 6-week metric, or the 6 steps to kind of make meaningful difference towards your project. So identifying the goal is starting with that, and then realizing your project, building up to scale, building in KPIs, looking at how do you leverage the power of open source in order to customize your software, build a community around it, and then finally give back to the community, right? So this is a proven model that we have done before with our experiences. So I think it'd be a good step for us if we could inspire you on this journey. Yeah. All right. So
That's it.
thanks
Thank you.
again for your time. So really appreciate you guys here. So we are open to any questions. By the way, this is the book that both of us wrote. It's on Amazon. Feel free to kind of look at it. Yeah. Thank you so much. So we are open to any questions. Thank you.
Yeah, we didn't plug the book. There he comes. Here she comes.
Hey, thanks for the talk. That was great. When you talk about energy, you obviously mean electricity, right? Like in South America, when they say lose, they mean electricity. No, I lose means there is no electricity. But could this extend also to stuff like natural gas or hydrogen? Could you create messages to measure that? My wife works in a food processing plant where they still use a lot of natural gas, for example.
Absolutely. I've done a lot in the water space, either commercial water or reusable gray water, or even oil and gas, where we're recycling used frac water and that kind of stuff. We measure all of that through flow meters and pumps, all the way to commercial usage, and look for things like leak detection or where water is being lost and we don't know why. I think from a gas perspective, I did show the Grafana graph where I'm just doing the metering, simple metering to see how that's doing. But the flow meters are there, so you can certainly measure that and monitor it just like anything else.
So all the rest of the architecture remains exactly the same, right?
Absolutely.
Okay.
You look at different energy sources and different connectors to kind of
Great.
get the data. Yes.
Thank you very much.
Any other questions?
All right, guys. Thank you very much.
Perfect. Thank you.